Chapter 6.3. We are going to be continuing with normal distribution, so we will still be using the Z table that we talked about in the last section. So be sure that you have that available to you. Now in 6.3 we will be doing application, and application means real life problems, which means real life values. Real life values are your raw scores. So what's going to occur in these application problems is you will be given X values or raw scores. So first you will be required to convert those to their equivalent Z values, which are your standardized numbers. Then from there you'll go to the table to find the probability. Now remember, in using the table, if you have a less than, you use the number from the table. If you have a greater than, you have to do 1 minus the number from the table. And if you have two values, then you take the larger one minus the smaller one. So if you look in this first problem, it says find the probability that X is greater than or equal to 2. We have an X value or a raw score. We're given mu and we're given the sigma, or the standard deviation. So the first thing that we need to do is to convert that to its Z value. And that is X minus mu divided by sigma. So we have 2 minus 3 divided by 0.25. So 2 minus 3 divided by 0.25, I get -4. So my standardized value, or my Z-score, is -4. Now, I have a greater than, so I know when I find the probability that X is greater than or equal to 2, before I even go to my table, I know since I have a greater than, it's going to be 1 minus the number that I find from the table. Sorry, I'm having a hard time writing today. All right, so we're going to go to -4. So I go to the Z table, and the largest number is -3.49. So if you recall, at the bottom of the table it says for values of Z less than -3.49 and -4 is less than that, use 0 to approximate the area. So the number that I find from the table in this case, which doesn't happen very often, but in this case is 0. So we have found that the probability that X is greater than or equal to 2 is equal to 1 minus 0 is 1, and that would be your answer. Again, doesn't happen a lot, but I did want to throw an example in there to show you that it can happen. All right, here we have that the probability that X is between 10 and 26, so we have X values. So the first thing that we're going to need to do is to convert both of these X values into Z values. So I'm going to take 10 minus mu, 15, divided by 4, and then we also need to take the other X value, 26 minus 15, divided by 4. So in this case, we need to find two Z values. So when you take those to your calculator, you're going to calculate -1.25. And then in the second one, you will calculate 2.75. Now, what we're going to do here then is go to the table. So I'm going to go to the Z table, -1.25 .1056. So on the table, this gives me 0.1056. Now I'm going to do the same thing for 2.75. So 2.7, this is 0, 1, 2, 3, 4, 5. So there would be 2.75, 0.9970. So what we know is when it is in between, so the probability of X being between 10 and 26, the answer to that is when we subtract these. So I'm going to take 0.9970 minus 0.1056, and when we subtract that, we get 0.8914. So we're given an x. We change those values to their equivalent z values so we can use the table. We find the numbers from the table, subtract those, and we get our calculation. Again, don't forget, probability will always be a number between 0 and 1. All right, next example. Police response time to an emergency is normally distributed, so that means we can use the z-table, with a mean of 8.4 minutes and a standard deviation of 1.7 minutes. And it asks us to find the probability that the wait is between 5 and 10 minutes. This is real life values, so they're x values between 5 and 10. So we are given the x values. So the first thing that we're going to do is we are going to convert both of those to their equivalent z values. So 5 minus 8.4 divided by 1.7, and also 10 minus 8.4 divided by 1.7. So I'm going to go to my calculator and calculate those. On the first one, we're going to get -2. And if you write just -2, that's fine. And then on the second one, you're going to calculate 0.94. And don't forget that as you are calculating z values, you always round to 2 decimal places, and that's because that's how the z-table is used, is to 2 decimal places. So I'm going to go to my table. -2.00 is 0.0028. Was that right? 0.228, sorry. There we go. And then go to 0.0.90123.8264. So then, to find this probability, the probability that x is between 5 and 10 will be the calculation that we get when we subtract these two. So I'm going to take 0.8264 minus 0.0228, and we get 0.8036. And again, it's a number between 0 and 1. Then the part B to this says find the probability that the wait is less than 5 minutes. So x is less than 5. Since it's a less than, all I have to do is go and use the number from the z-table. Well, we're going to calculate z. Well, we actually calculated that in part A. It was 5 minus 8.4 over 1.7. We found that to be -2, or -2.00. Since it's a less than, I just use the number from the table, which we actually did in part A, so 0.0228. And I'll write it this time so I don't have to scribble. So that's how you apply these. Let's look at another example of application. All right, we have the cassette deck life is normally distributed. So normally distributed meaning that I can use the z-table. We have a mean of 2.3 years. I've written that here. And a standard deviation of 0.4 years. That is written here. We want to know the probability that a cassette deck will break down during the guarantee period of 2 years. So what we have is the probability that it will break down. It's guaranteed 2 years or less. So x is the breakdown period is anything less than, or let's see, during the guarantee period of 2 years, so it'd be less than 2 years. So I have my x value. It's a less than, so I know all I have to do is use the number from the table. So what I'm going to do is convert that to its z value so I can actually use the table and get 2 minus 2.3 divided by 0.4. I'm going to put that into my calculator, and I calculate -0.75. Now I'm going to take this to the table. It's a less than, so I just use the number from the table, -0.75. negative 0.7, 0, 1, 2, 3, 4, 5, 0.2266. So, now what that basically means is 22.66% of those sold are going to break down in the guarantee period. It's what we have just calculated. Now, what we have been doing is we have been taking real life X values, converting them to their equivalent standardized Z values, going to the table and finding the probability. And the next part of this section is doing that in its inverse. So now, instead of finding the probability, we will be given the probability, and it will be typically given to us as an area, which means it's given to us as a percent. So we will be given the values in here. We will work our way out to find its Z value, and then in turn be able to find the X value when it asks for it. So if you'll notice in this first one, it says find Z. So we do not have Z if it asks us to find Z. What they tell us is this is how much of the curve is shaded in, and it is shaded in to the left. All right, well, here's mu, and if I shade to the left from mu, I've shaded in 50%. And this is telling me to only shade 5.2%. So, knowing that, I can guesstimate and shade about 5.2%. So if we shade this in, and we're going to say that we have 5.2% shaded in, well, on our table, it's not given as percents, it's given as decimals, so I'm going to convert this to a decimal, 0.0520. This is the number I'm going to look for on my Z table. Now, what I can figure out is I do know based upon the amount that is shaded that my Z value is a negative number. So I'm going to go to the negative Z table, and I'm going to try to locate 0.0520. So here's 0.03, 0.02. I need 0.05. Here's 0.04. Let's see. Come over here, 0.0520. So let's see, 0.0520. Here we go. I find 0.526 and 0.516. So it's in between these. So the number that we're looking for, 0.0520, would fall in between these two values. So here's what I'm going to do. We're looking for 0.0520, but what we found was 0.0526 and 0.0516. So when the value that you're looking for falls in between two numbers, what you're going to do is ask yourself, which one does this fall closer to? Such as if I subtracted these two, the difference in these two is 0.0006, and the difference between these two is 0.0004. So it tells me that it falls closer to this one, so that is the Z value that I'm going to use. So I go back to my table. Here's where it fell in between. It is closer to 0.0516, so we're going to use the Z value of negative 1.63. So this goes with negative 1.63. So the Z value that I'm looking for is negative 1.63. And this is what it asked me to find. It said find the Z. Now, students typically have a little bit more difficulty doing the table in inverse. So we're going to do a few more problems because there's some different scenarios that can occur. Look at this next one. It says find Z. So again, if it asks me to find Z, I don't have Z. It does tell me to shade in 5% of the curve, but this time, this 5% is shaded to the right. So I'm shading in 5% to the right, so I'm going to be coloring in to the right. Well, at mu and to the right is 50%, and that's way too much. So I'm going to shade in, whoops, sorry, my paper is moving. This is 5%. That's what we've shaded in. Now, I can look at this and go, okay, I know my z-value is a positive number, just based upon how much we shaded and in what direction. But my table is left-tailed. So I am going to be looking for, on the table, that amount that is to the left of this, which is the non-shaded, which is 95%. And again, I knew that because 95 plus 5 is 100. So we're going to be looking for 0.9500. This is what we're going to look for on the table. On the positive side, so I'm looking for 0.9500. Well, there's 9573. 9599. Let's see, I'm going to 95. Here's 9505. All right, so 9500 is going to fall right in here in between 0.9495 and 9505. So the two values we're looking for 0.9500, and the two values that I found that it fell between was 0.9495 and 0.9505. So it falls in between those. Now, again, which one does it fall closer to? Well, if I subtract these two values, that's a difference of 0.0005. If I subtract these two, I get a difference of 0.0005. So it falls smack dab in the middle. So here's what we do. We're going to locate those two z values. So I'm going to go back to the table, and I'm going to look where that falls. So it's 1.64 and 1.65. So this one is 1.64 and this one is 1.65, and it doesn't lie closer to 1, so we're going to take these two z values and we are going to average them. So I'm going to add 1.64 plus 1.65 and divide by 2, and what I get is that my z is 1.645. Z equals 1.645. Now, this is one of the very few times that you'll get a z value that is 3 decimal places. But your z in this case would be 1.645. All right, let's look at another scenario that will occur. And that is when, again, we're finding z, but now it is going to tell us the amount that falls between z and negative z. Now, it will fall symmetrically, so when it tells me 90%, what it's telling me is this in here is 90%, and it's symmetrical. So what that means is, under the whole curve is 100%, so if this is 90%, I have 10% left, so this would be 5%, and this would be 5%. And these two z's that I'm looking for are opposites. So what that means is if I find this negative z and say I get negative 2.25, then I know this is positive 2.25. Or if I find the positive z first and I get 1.78, then I know this is negative 1.78. Now, remember that our table is left-tailed. So to find the negative z, and again, once you find the negative z, all you have to do is get its opposite, and then you have the positive z. So from this vertical line to the left, we know is 5%. So I'm just going to look for 0.0500 on the negative, because we know this z value is negative, I already know this is negative, and I'm going to look for this value on the negative side of my z-table. So, let me get a different z-table because I've written on that one so much. Okay, so I'm looking for 0.0500. 0.0500. Well, here's 0304. I want 0500. Well, I find these two, and it would fall in between these. 0.0505 and 0495. So, the number we're looking for, 0.0500, falls in between 0.0505 and 0.0495. Now, again, which one does it fall closer to is what I first ask. The difference between these two is 0.0005, and the difference between these two is 0.0005. So that tells me I need to find the two z values and average them. So I'm going to go here and up, and I get negative 1.64. So this is negative 1.64, and this one is negative 1.65. And we're going to average these two, which means add them up and divide by 2, which will give you negative 1.645. So there's the z value. Well, once I've calculated this one, I know this one is its opposite. So this is positive 1.645. And that's how you find it when it falls in between. All right, now let's take that and apply and see the situations where you might encounter this. Okay, this reads, the probability that x is less than some number. Well, since it's labeled x, then I know that the number I'm looking for is a raw score or a real life value is what I'm looking for. And it equals 12.3%. So the probability is what it's giving me of 0.123. So this is the probability is what's given. Now it's a less than, so that tells me my shading is to the left. So I know I'm going to shade in to the left. Well, again, from mu to the left is 50%, and I'm shading less than that. I'm shading 12.3%. So I'm shading this amount, which is 12.3%, or 0.123. So this is the number I'm going to look for the table on the negative z-value side. Let me get another one because I keep writing on these. All right, so on the negative z-table, I'm looking for 0.123. 0.123. And lo and behold, yay, it is so nice when that exact number is on the table. So my z value is negative 1.16. Negative 1.16. So we have found z to be negative 1.16. Now, be careful, don't stop here. It asks you to find x. We have found z. So now what I need to do is take this z value and convert or calculate its equivalent x value. And if you remember, that's z times sigma plus mu. So we're going to take negative 1.16, the z that we found. We're going to multiply that times sigma, which was given as 2, plus mu, which was given as 17. So when I put that into my calculator, I get 14.68. So here is that x value is what we were looking for. All right, I want to look at an application problem in the book. So if you will turn to page 288, let me get there myself. And we are going to look at number 30. It says, Acrotime is a manufacturer of quartz crystal watches. The researchers have shown that watches have an average life of 28 months. So I put mu equals 28 months because that's the average life before certain electronic components deteriorate. The standard deviation is 5 months, so that's where I get sigma equals 5 months. All right, so part A, it reads, if an Acrotime guarantees a full refund on any defective watch for 2 years, all right, so 2 years is its guarantee. This is a raw score, which tells me they have given me an x value. So when they give me an x value, it says what percentage. Well, it's asking for what percentage. Percentage is area, so this is giving me the x. I have to find the area or the probability. So we're looking for probability in this case. Guarantee, x is a real life value. It's guaranteed for 2 years or less. Now, one thing that you need to notice in this particular problem is this x value was given as 2 years. Mu and sigma were given as months. So in order to do my calculations, I need to rewrite this as months so I can actually do my calculations. So the first thing I'm going to do is find its z value, which will be x, 24 months, minus mu, 28 months, divided by sigma, 5 months. So I'm going to do that. X minus mu divided by sigma, and we get negative 0.80. So now I have a less than value, so I know I just used the number from the table. So negative 8.0, that would be 0.2119. Which basically says 21.19% of the time, then you are giving refunds on your watches. All right, part B, it tells us we're going to apply the inverse. So that means they're going to give me a percentage or the probability, and I have to find the x. And it reads, if Acrotime does not want to make refunds on more than 12% of the watches, how long should the guarantee period be? So we're looking for the probability that x is less than some number. This is what we don't know. What we do know is they don't want to do it any more than 12% of the time. Report 1200. Now it's a less than. You don't have to draw the picture, but if I'm shading to the left and I'm shading 12%, what that tells me is that I'm looking for the z on the negative z table. So I know z will be negative. So I'm looking for 0.1200. 0.12, here's some 1-2s, 0, so 0.1200 is going to be between these two numbers. And if you ask which one is it closer to, it is the same distance or difference between this and this. So that means I need to average these two z values. So we're looking at negative 1.17 and negative 1.18. So we have negative 1.17 and negative 1.18, and you have to average those, which you get negative 1.175. So that is the z value that we use, but what we're looking for is x. So x is z, negative 1.175, times sigma was given as 5 months, plus mu was given as 28 months. So when we do those calculations, we get 22.125. And it told me, let's see if I go back to the problem, it says, how long should the guarantee period be to the nearest month? Well, that is nearest 22, so 22 months. So when they guarantee 24 months, then they have to replace the watch 21.12 or 19% of the time. If they just cut off 2 months and only guarantee it for 22 months, now they're only having to replace the watch 12% of the time. So that completes 6.3.